from chapter 3 the other day, and we're going to graduate and move to chapter 4, which, in all honesty, is probably one of my favorite chapters out of this textbook, because it's discusses an area that to me is one of the most important things that we deal with, whether we're talking about plant production, animal production, or just our own daily lives. And I'm going to ask you a question for any of you, all of you. What's the climate like in your area today?
Kind of cloudy, overcast, cool.
Okay. You didn't catch what I did to you. I used the wrong word. You gave me the weather conditions. And that's what I should have asked you. But I was trying to see if anybody caught it. But the term climate refers to what you stated, but over a longer period of time. It refers to the amount of solar radiation we get. In other words, that cloud situation that you mentioned. It refers to which that regulates temperature. And then rainfall, wind direction, and speed are all components of the climate, but the climate is over a longer period of time. We're talking about, a year to 5 years or 10 years. It's a greater span of time. The terms climate and weather are quite often confused amongst folks as we talk about this. So the variation and instability in climatic factors are actual elements of the weather that we deal. So you answered the question, what is the weather like in your area today? And as we move through this chapter, we're going to compare and contrast the differences in weather in your area, in Southside, in our location here at Patrick Henry, as opposed to what's going on in Southwest, which is one of our sister colleges in this consortium. So, but weather is defined as the actual values of climatic variables, and weather is not the same thing as climate because of the differences in the time frame that we are concerned about. And solar radiation determines and influences all the variables that make up the climate. And the solar radiation is going to vary with the latitude and the seasons.
And the hole in the ozone.
Do what?
And the hole in the ozone.
The hole in the ozone is a different animal. That's not a component of the weather or the climate either.
Oh.
That's a factor, but it's not what we speak of with those conditions. Climate can be modified by local features such as altitude and the presence of land and water. And as you know, in past semesters, we've talked about the differences in the altitude or the area above sea level for each of our locations. Tom, refresh my memory. The altitude where Alberta is it 600 to 700 feet, something like that?
You asked me that a couple weeks ago, and I forgot to check.
That's okay. That's what I remember.
Or maybe I did
It's
check.
less. It's less than 800 feet anyway. Where Tyler and I are sitting here at Patrick Henry, we're at about 1,000 to 1,050 feet above sea level. My house, my driveway, point right at the end of my driveway at home, is 1,175 feet, because I've got a national survey marker right at my driveway. So that is,
I just,
397.
yes, that's what I just found. 397 for here.
397, oh, that's not as high as I thought it was. Okay.
Yes. And Keysville is 676.
Okay.
So,
So when you leave Alberta and go to Keysville, do you feel like you're driving uphill?
there's no good way to go from Alberta to Keysville.
Well, but that's what I'm getting at. You know, in areas like where we reside, there's not a tremendous noticeable difference. But as we think of climatic factors, it does make a difference. And here we're at about 1,000 feet. I'm almost 200 feet higher at home, and I don't recognize the difference in the elevation as I move up. But that will constitute a difference in temperature. Here in Martinsville, average temperature most of the summer has been 3 to 4 degrees warmer than it is in my house. And then early morning or the low point in the day, usually sometime during the night, it will be 4 to 5 degrees cooler here in Martinsville than it will be at my house. Why?
Difference in elevation.
There's a difference in elevation as part of it, but why?
Because the higher up you go, the cooler it gets.
Well, I'm higher at home, so it should be during the night. It should be, with what you're saying is correct. It should be cooler at my house, but it's not.
I cannot offer a good reason then.
That's part of the reason we're talking about it. When air cools, it becomes more dense. Cold air is more dense than hot air. That's how, that's why these hot air balloons will rise, because they heat all the air that puts a lift, makes it a lot lighter, so it will carry a basket up in the air. But cold air being more dense, it will flow just like water. It moves in a downward motion. So, the air from the area where I am, in essence, in practicality, will move to the area around Martinsville. It moves downhill. And it's also a contributory factor is that there's a major river that comes through this area, the Smith River. And the rivers will funnel cold air or cooler air down into areas. So, and as we talk about the differences in elevation, like I said, I'm at 1175, but I can look out the window to the north of my house, and I can view the crest of the mountain, the edge of the Blue Ridge, and that's at 3,000 feet. Ooh. So in an average day, the temperature at my house, say, would be 80. The temperature on the crest of that mountain is going to be 74, 75. Normally, during the winter, there's a 10-degree difference between my house and the mountain because of the differences in the elevation. Now, where Dwayne, the guy that used to help us with our animal science class, he was teaching at Southwest Virginia Community College, and they were at about 22 to 2,500 feet. I'm not sure exactly the number. But Dwayne lived on a mountain west of there, and his house was at 3,300 feet.
Right. Wow.
And it was during the December, January, February, and March, it was always interesting to compare the weather conditions between Dwayne's house, my house, and here. We might be getting a 40-degree day with cloud and mist. Dwayne would be 31 to 32 and having snow. Every time it got cloudy out there, some winters it would snow. Dwayne had a nice four-wheel drive vehicle, and he had to activate the four-wheel drive to get home most days during the winter because of the snow that would accumulate. So, climate, like I said, it's modified by altitude, and that's what we're talking about there. It's also modified by the presence of water. There is a considerable vegetable production area in an area called Benton Harbor, Michigan. And it's on the southwest side of one of the Great Lakes. And it escapes me which one, but that doesn't really matter. But they have a real good vegetable niche in the market from about this point in the season until about the 1st of November. And we're talking about Michigan. And would you think that to be a viable location for a late season vegetable crop?
Not really.
Okay. Because you're thinking of just the term Michigan and it being northern and colder. But the fact that Benton Harbor area, it's good, fertile, flat land. But again, I said it's on the southwest side of that lake. And the air and the climatic conditions, in other words, the weather conditions that exist there during that period of time, is tempered by the air coming off of the warmer water that exists in that lake, one of the Great Lakes. So, if you get 200 miles inland, the temperature may be 35 degrees, but it's still going to be in the 50s there in that area near the lake. Same thing in the Great Lakes, in the area around Erie, New York. There's quite a fruit production area in that where apples, peaches, plums, and grapes are grown because of the tempering of that air temperature during that season. Now, in the reverse, in the springtime, as we talk about this, we'll be getting 45, 50 degree days, and you'll hear about Erie, New York getting 18 inches of snow. It's the reverse of that lake effect situation because that water is still cold, and the air coming across that lake gets saturated and chilled, and when it reaches the land, it drops the snow. So they may get a foot to 18 inches of snow within a narrow band along the cold side of that lake. That's what you call lake effect snows that exist. So those features contribute to what we call a macro climate. That means a macro being larger. It's a larger effect, a climatic effect over a larger area. Now, in contrast to that, we will have different climatic conditions that occur in small areas. I use my grapevines as an example, or you could use your maple tree or your oak tree that you have in your yard. The temperature and humidity that exists out in the yard, you may have 85 degree temperature and 60% humidity, at 4 o'clock in the afternoon, in your yard. If you've got that large, dense maple tree in your yard, the temperature underneath that tree may be only 75 with a 90% humidity. And that's an example of what we're talking about microclimate. It's a smaller area. So you've got contrast, differences that are created by external conditions. Those small effects can be caused by buildings, ponds, ground depressions, or even things like trees or my grape canopy. That's one of the things that we're primarily concerned about with grape production is the density of that canopy and the air movement that exists within that area. It changes. If we have an extremely heavy, dense canopy, the air doesn't move. We'll have more moisture condensed in that area and greater disease pressure. So we have to do what we call canopy management in a grape canopy to reduce the number of shoots and actually pull leaves off to allow this microclimate to be altered and allow increased movement of air and water to reduce disease pressure. climate determines the kind of natural vegetation that grows in an area. And the vegetation itself has a moderating effect on climate. Any of you noticed or watched any of the reports from down in the Caribbean islands and the effect that the tropical storm had on the vegetation and the trees and so forth? And you were paying attention to? Carol, did you start to say something?
Yeah,
One
no,
of you?
I haven't been watching anything about that.
Okay. One of the news reporters that I heard doing a report from down there, and this was probably early part of the weekend, they said that all the vegetation just looked burned. They had so much damage caused by the high winds from that hurricane that it's taken a lot of the leaves, the limbs, and so forth off of those. But in a normal condition, these tropical areas that are wooded, they'll have tropical rainforests and tropical areas. The area, the temperature, and the radiation, the solar illumination at the tops of those trees is greatly different than what's at the bottom. The canopy is dense enough and creates so much shade at the bottom that you don't actually have much vegetation. So this hurricane has dramatically altered that scene, and it's going to be really interesting to see what happens with those. Some of those trees are going to recover and some won't, and it'll be interesting to see what happens to the ground cover and vegetation that there. That vegetation has a modifying effect on what's there, and the absence of the vegetation is going to actually modify the climate that exists at ground level. Human activities modify climate, sometimes to the benefit, sometimes not. If we compare, I'm not familiar with the campus at Alberta or Keysville, either one, but I imagine you've got some green space, got some lawn or green space there in either one of those locations. And
Yes.
say, was that a positive? Yes?
Yes.
Okay. If we were to compare the temperature at 3 o'clock this afternoon at a foot above the ground in that green space that you're talking about, I can imagine that it probably would be 83, 84 degrees, something like that, based on the weather forecast that I've heard for today. And you have parking lots. Most of your parking lots, I would imagine, are paved rather than gravel. So what would the temperature be a foot above that asphalt in the parking lot at 3 o'clock this afternoon, if we had 83 or 84 above your green space?
90?
More than likely, at least 90. So what I'm getting at, the differences between an unpaved versus a paved is a human effect, and it has modified the climate in that small area. Same thing as if you listen to the weather reports, and they'll say forecast today is calling for, and this is in mid-July, they'll say that temperature at the airport is going to be 88 today, but downtown they're expected to be 94. Why?
Downtown, it's a lot more people.
What you say is true, but that's not what causes the difference in temperature.
Vehicles. I said vehicles causing heat.
Vehicles will add a little bit to it, but not so much. What actually happens is that urban area will heat up over a period of time, and actually bank or store heat. And at the airport, it's much more open. I'm using that just as an example, but it, you know,
Closest to the urban buildings acts like a heat sink.
the buildings act like a heat sink, exactly, Tyler. And you know, one of the most uncomfortable places that I've ever been in the summertime is either Richmond or Washington, D.C. because of the heat that's stored in all that stuff. You just don't cool off. And that's an effect of human activity. They have, in essence, modified their climate. Forested areas are much cooler, but as we know, there's been a lot of timber cutting, particularly in our area, and I think in Southside there's been a lot of timber that's been cut. But they've cut a lot of the timber around on the ridges and the sides of the mountain to the west of us, which has an effect on the overall temperature in that area, and I think it's created some more severe thunderstorms than what we used to get 20 years ago because of the heating of the land and the updrafts that occur from that. It's another effect of a human activity. Dust and pollen, pollutants generated by human activity will affect the climate and possibly can increase rainfall. What is smog? What we talk about smog. What's smog?
Air pollution.
It's air pollution, regardless of the source, whether it's automobiles or manufacturing or whatever. But that has an effect on temperature and, in theory, potentially rainfall. One of the worst smog areas that I think exists now is in some of the Far Eastern countries with China and possibly Japan. They're constantly having issues with air pollution over there. As we talk about these climatic conditions and things, our wild or our native plants have evolved and gotten to the point that they can survive under the climatic conditions in their natural habitats. They don't do well if you move them out of their natural habitat unless you create something similar. So these are called ecotypes that will adapt to the changing conditions. Says one ecotype might have a greater tolerance for cold and require a shorter growing season or a longer day length for flowering than another one. We're going to have an event this week that is kind of monumental in a way. Do you know what I'm speaking of when we talk about an event this week? It's 4 days away now.
On Saturday, the supposed end of the world.
No. We're not going that way.
My family going on a camping trip.
Yay. Where are you going?
Well, that'd be nice. Where are you going?
Oh, we're actually going to the Curd Dam.
He's coming to my house. Cool.
You can go visit him.
Yeah.
Well, now
I'm not going to tell you
there's
where,
gonna be
but
activities
I know people that,
going on.
if your kids want to ride ponies, let me know.
oh, my daughter would, but anyway.
Appaloosa, they're ready for her.
In Appaloosa.
Oh, yeah.
Sarah will take that Appaloosa home with you. She will beat you up for that horse. I just warn you now. She's only 9, but she's fierce.
Be prepared to bury your daughter.
And Appaloosa is her favorite, so just be warned.
If she tries, be prepared to bury your daughter.
Just be warned. Well, you're going to have to work at it to kill her. Just be warned.
She doesn't know what she's got coming.
But anyway, so what event is going on? Besides the
It's
Rumble?
Friday. The Friday is the day I'm speaking of.
Oh,
It's
yeah,
of significance.
yeah, Saturday's race in Martinsville. Yeah, under lights.
Yeah.
Yeah.
This
Sorry, no.
Kristen, isn't her name? Simmons?
What's going on Friday? Am I gonna Google it?
Anyway, I don't know.
Well, I'll give you a hint. That race in Martinsville is going to take place in another season.
I know.
Fall,
Oh, yeah,
What was that, Tyler?
becoming fall.
Yeah, at 4:04 on Friday afternoon, fall begins.
Today's the 20th, correct?
So that day
No, it's the 19th.
is also referred to as the equinox, which means what?
The fall equinox, change of season.
Changing of seasons.
Yeah, changing seasons is right, but
Isn't it eclipse too?
no. Eclipse is
During
a
solstice.
month or so.
No, but,
Long for shorter days,
but the equinox is, the equinox is triggering the change of the seasons. What is the equinox that is the indication of the changing of the seasons? That's the question he's asking. Something to do with the moon, as I recall.
It's actually the sun.
No, it's not the moon.
Or the sun.
He'll tell you. I'm just,
Well, the equinox means, and it takes it right from the word equal. We have equal day and equal night for that particular day.
not the moon. Yes.
And so at that point, the sun is directly over what?
Our side of the earth.
Well, yeah, that's true, but it's directly over the equator. That means that it's sun shining right straight down. And as the earth begins to tilt, it's going to move in the other direction. It's going to go south of the equator, which is going to mean that our days for the next period of time is next quarter are going to become shorter. So until about the 18th, the 20th of December, from Friday, our days are going to get shorter because of the changes in the radiation and the tilt of the earth. So, that occurred. We have equal days and equal nights at the beginning of fall, beginning of spring, and the beginning of fall. That's when the earth moves over the equator. So that's not particularly in this point, but we'll talk about it at some point.
That's what I meant by having something to do with the moon. Yes.
What was that, Tom?
I said, that's what I meant by having something to do with the moon. I knew that.
Yeah.
I wasn't thinking.
Yeah.
I panicked.
But our plants that we grow, some of them are affected by long days, some affected by short days. So from Friday going forward until we get to say the 20th of December, just for our argument purposes, that our days are going to be getting progressively shorter. And then at that point, winter begins, and that rotation will begin to tilt back. So our days will get longer until we get to another equinox, which will occur about the third week of March. That's when the sun will come back to the equator again. So,
What date is the, from your clock back?
I couldn't hear you. Nick. Try again.
When do we fall back? When's the date of when we fall back?
That's usually about the third Sunday in March, I think.
Oh, it's not.
Oh, but
Yeah.
we fall back here like the,
Fall back. That's in about the second week in November or something. I get that, all that mess confuses me. I'm more concerned with the natural phenomena rather than the human manipulation.
Yeah, well, everybody says it affects them. Well, not
Yeah,
everybody.
and it creates some confusion. I hate to have to change all my clocks. I can't remember from 6 months from what I have to do to change the clock on my truck. So that's bothers me. Anyway, that's what we're talking about with the natural phenomena that occurs. And that natural phenomena has a direct effect on our weather. And, you know, why, if the 20th of December is the beginning of winter, why isn't that the coldest day of the year?
Because it's just the beginning of the winter.
It is the beginning, yeah.
Is it because we're tilted furthest away from the sun?
Well, that we are tilted away from the sun, right? And the radiation is reflected more than it is at this time of the year being directed straight at us. But no, it's a little like what we were talking about with the bodies of water. All of the land has been heated through this summer, and we are cooling from this point on as the days get shorter, and it has a banking effect or residual effect that everything is gotten a lot of heat in it. So there's usually a lag between the shortest day of the year and the coldest day of the year. Normally in our region, the coldest week occurs about it begins 16th to the 20th of January. So that's usually the point that's the coldest. And here, our hottest weather usually occurs about last week in July to the first week in August. So it's a result of the whole system and the way it's put together as a result of the radiation that is expended on the earth as it is. And it makes it, to me, really interesting.
Yeah. And actually, we see it on a day-to-day basis. The coolest part of the evening isn't the middle of the night. The coolest part of the evening is an hour or two before sunrise. And same thing, the hottest part of the day isn't 12 o'clock, 1 o'clock in the afternoon. It's a couple hours before the sun goes down, because we've accumulated all that heat during the day. We've accumulated the cool over the night. And so it's storing up the same way on a day-to-day as it does for the season.
And if any of you are deer hunters and like to go out, deer hunting and be there early in the morning, the point in the morning at which I freeze to death is about the time the sun begins to illuminate things. About the time you begin to get the first sun's rays on you is the coldest time of the day. And for that reason, folks that are growing plants, strawberry growers are a good example. They are really concerned about frost, and that frost will occur generally after the sun comes up, when you begin to get sunlight on the plants. But that's the point at which it's the coldest. We hadn't talked about this at all, but when we were talking about weather, do you have any idea how the temperature is measured by the NOAA weather forecasters and all the weather stations, where that temperature is taken? It makes a difference.
I'm guessing on rooftops.
Nope. But I'm glad you said that. We'll contrast that.
On a hill.
No. Go ahead, Carol.
I said 5 feet off the ground.
Exactly. Weather for comparative purposes in all locations by national weather forecast and reporting stations is taken at a point 5 feet off of the ground. That's to create a uniform reading. Now, at 5 feet, say we're talking about April 1st, that temperature at 5 feet on April 1st at 7 o'clock in the morning may be 40 degrees. But where those strawberry plants are growing is 5 inches off the ground. So between that 5 feet and 5 inches, what do you expect the temperature to be? If it's 40 at 5 feet, what do you expect? And we're talking about an open, clear,
Is it 5 foot off the ground?
5 feet off the ground. Now, this is in a location on a morning when it's bright and clear, no clouds and no wind.
I would say it'd be somewhat cooler, closer to the ground.
You're right. It's going to be quite a bit cooler. More than likely, if it's 40 at 5 feet, it may be 30 at 5 inches. So, there's a microclimate. There's a difference in there. Now, what if we had that scenario and it was heavy clouds, 40 degrees at 5 feet and heavy clouds?
Probably going to be below freezing, about 5 inches off the ground.
Nope. I'm glad you said it, though. That cloud cover acts just like that blanket that you had on you during the night. It creates a ceiling for the temperature that's being radiated out of the earth. So that cloud cover, anybody growing strawberries wishes for cloudy nights because they don't lose the radiation and they don't have to worry about irrigation as much. But clouds will create a ceiling and hold the natural heat in, so you won't get that dramatic variation. Now, what if we're talking about same scenario, 40 degrees, it's clear, and we have a 10-mile-an-hour wind?
It's going to be warmer towards the ground
Warmer than what?
than 5 feet.
No, I don't know that it'll be warmer, but it won't be as drastic a change because the wind is going to mix the air. It's going to be just like you're in your house and you turn on a ceiling fan. You're uncomfortable with it before you turn the fan on, but that ceiling fan is going to mix the air in your room. So it's going to dramatically change. And these are little things, and I'm not really following the PowerPoint when we go to talking about that, but I think they fit into our discussion with the way we're talking about this. All right, solar radiation is what provides all of the heat that Mother Nature provides for us, and that big light bulb that we've got in the sky is a huge, it's the only reason we're existent. And that big light bulb provides a radiation for photosynthesis. And there is a tremendous difference in the wavelength that comes from that big light bulb. But plants can only use that radiation in a fairly narrow window, just a small range. So if we're looking at a wavelength from 0 to 2000, the photosynthetic active radiation that is used for photosynthesis is between 400 and 700 nanometers. And that gets to be a little technical, but that's the visible radiation that plants can use to produce carbohydrates and sugars. So, that gets into the skinny of what we're talking about with solar radiation. And the intensity of the solar radiation varies with it's highest at the equator. That's why we call the tropics, and the high intensity radiation supports a different type of plant life than what we have in Southside or Southwest or Patrick Henry. So, that's the deal. And as we move north or south of the equator, the intensity of that radiation is decreased by the latitude and the tilt of the earth. That's why we get the seasons that we do. The movement of the sun to the north and to the south, and then the tilt of the earth. So that's why we're talking about the event that occurs Friday, with it being an equinox. That's when the sun is most directly above the equator. And then as we begin to tilt the earth, it will move south of the equator, and instead of getting that direct radiation, it's going to be somewhat reflected. It's going to hit the earth's surface and bounce away. So that's what we're talking about. It says the light intensity at noon at 40 degrees north is about 60% of the value of what it is at the equator. So because of the shape of the earth and that tilt, it reduces the intensity. Okay? What do clouds do for us as we talk about solar radiation?
Well, they do help provide some form of cover, but they also kind of trap heat in a little bit. They don't
Exactly.
do a lot of cover, but they do some cover.
Mm-hmm. All right. Have you ever gotten sunburned on a cloudy day?
I haven't, but
Yes.
I've heard of it.
Yep.
I've heard of it.
Yeah. The clouds are effective in absorbing some rays, but not everything. So the UVB rays will come through and actually create damage to your skin that you're not aware that you're getting, because you're not getting as hot because of the UVA rays that you get. So that's one of the differences that occurs. All right, I've kind of badgered you with a lot of stuff this morning, but that's what we're talking about when we talk about the differences in climate and weather. And the two terms can be somewhat confusing, but climate is the summary of the conditions that exist over a longer period of time, where weather is the spot conditions. We're looking at the same parameters, the same things, but it's the period of time in which we're evaluating them that makes the difference. Okay? We're about out of time, so I just wanted to kind of close with that. And if you got questions, don't let me confuse you. Be sure to, the only bad question is the one you don't ask. So,
I do have.
challenge me. Go.
I know you said we want to get through this chapter before we do our first test, but when it comes
Yeah.
to the test, I noticed the vocab study guide on Blackboard, but I wanted to know, other than vocab, what else should we expect?
I didn't catch the last part you said.
Other than vocab on the test, what else should we expect for our first test?
Yeah, the study guide that's in there, it's going to cover 1 through 5.
1 through 5.
Mm-hmm.
Is it,
Well,
some of them have acronyms, and I know there's other acronyms that you have used. Should
yeah.
you know the acronyms?
I hate acronyms. Most of the time we'll use the real stuff. I'm sorry, I'm old school, and I need all the hand holding I can get. So most of the time I try not to do. I'm not going to ask you what NOAA means. The National Astronomical Weather. So we'll deal with it as we get a little closer. I got a couple emails from folks worried about the test, and my syllabus is a tentative thing, and I'd much rather us discuss stuff and go over it, fairly thoroughly, rather than breeze through it and give you stuff that you don't understand. My goal is to create an understanding with you, whether or not we cover the entire book or not. So, in most semesters, I rarely ever get past chapter 9, but that's a lot of the content of what it was. This is an introduction to plant science, and I want you to understand the skills and the principles and stuff that's there rather than. So, I'm always eager for your questions, and let's play with it that way. Okay. I'm not here to punish you. Okay, thanks.
Apparently it's my job
Thank
to
you.
return.
Yes. Okay.
See you, John.
Bye, Mr.
All right, see you later.
All right. I'll be dialing back in a few minutes. Smoke them if you
All
got 'em.
right.